Hey guys, today's video is going to be really exciting. We are going to see a step-by-step demo on K-means clustering. I will explain this with a really simple example so you understand how to create a project on K-means. To start with, I'll be presenting where do we stand currently in this machine learning journey, what K-means is in short, and our main focus in this video is going to be on executing demo on K-means clustering using Jupyter Notebook and scikit-learn library. And not to forget, towards the end, I'm gonna talk about a really important topic, that how do we identify value of K, which is really critical for us to understand. And trust me, this is the most frequently asked questions by interviewers, and this is where most of us fail. We know what is K-means, but we don't know how do we identify the optimum value of K, which is nothing but number of clusters to create clusters. So make sure you watch this video till the end, and let's get started without wasting our time more. Hey guys, welcome to AI with AI. This side Asif Imnat. Alright, before I directly jump on the demo part and start showing you a Jupyter notebook, let me give you some idea about where are we in this journey of learning machine learning and how this K-means clustering works. I'm gonna spend some time on this, and then the demo part, which is our main focus. I know you might have seen this diagram multiple times in our videos, but just to quickly understand where are we now, a machine learning is divided into two types: supervised, unsupervised. Supervised is labeled data, right? Where we have a data which is pre-labeled, pre-categorized, meaning we have right answers already given. We need to find more right answers in supervised learning. Unsupervised learning, data is raw, data is not labeled, not categorized. We need to identify the patterns, look at the patterns, and then learn how do we cluster, how do we reduce the dimensions, so on and so forth. So we have already seen many algorithms under supervised, that is classification. Again, many algorithms under classification and many algorithms under regression technique with the demo, with the hands-on demo. So if you have not watched, I urge you to please go through the playlist of machine learning on our YouTube channel. Then currently we are here. We are learning first algorithm under unsupervised learning, that is clustering. We already understood what is clustering and what are the different types of algorithms that we have, which is the first algorithm which will help us in clustering, which is K-means clustering. So it's kind of the continuation of the previous video, that's K-means clustering, how it works using Jupyter Notebook and scikit-learn. Alright, so this is where we are. We still need to learn dimensionality, reduction, association, anomaly detection under unsupervised learning. We'll see that in the future. Let's quickly understand how does K-means clustering works. If you know how K-means clustering works, you can just skip this 1 minute and go for the demo directly. But for those who are watching it for the first time, let me quickly explain. So 3 simple steps. K-means clustering is very simple. So you have a raw data, something like this. Data is not labeled, it is unsupervised learning, right? Everything is in green, not labeled. Initially, it drops 2 seeds, blue and red. Goal is to create clusters. Goal is to divide this data into 2 categories. That's why 2 seeds. Now algorithm asks each data points by looking at the distances between them whom you are near to. So if the data point is near to the red seed, you become red, and if you are near to blue, you become blue. So this is how the data gets divided into 2 categories. The data points which are closer to red will become red, data points which are closer to blue will become blue. But story doesn't end here. This doesn't mean we have created optimum cluster. Now what algorithm will do, now it will move these seeds to the centroid. It will move to the centers of the new clusters which it has formed, something like this, and then reset. So the seeds are moved, they came to the centers of the new clusters, and then it will ask the same question again. So it keeps repeating the same thing again and again. So if you are closer to blue, become blue. If you are closer to red, become red. Again, move to the centers of the new clusters which are formed. And eventually what will happen at certain times, when you keep repeating these steps, the seeds will not move. And this is when you will identify 2 identical clusters, where you have minimum error, which is also called within cluster sum squared error. So we need to reduce this error, which is nothing but within cluster sum squared error. So now talking about the demo part, what are the steps that we need to follow? So steps to create a better machine learning model. We know about this. So I have prepared certain steps, certain process, which you should, or any data scientist, any machine learning engineer should follow, are these 8 simple steps. To start with, you should import the library. That is the first step. Whatever libraries you are using, NumPy, Pandas, Matplotlib, scikit-learn. Import those libraries, prepare the data which you want to work on, do the data cleaning, identify the features, which is feature engineering, which columns to look for, reducing data so that you can only focus on which has some value, which has some insights, right? So which is nothing but feature engineering. Then once you get the data, once you prepare the data, you scale the data, you reduce the data, you identify the important values, important columns, then you plot the data. This is the ideal way. So once you get the data, plot the data. Once you plot the data, you understand how data looks like, what is the nature of the data. Then the fifth step is for sure train machine learning model. Decide which machine learning model fits best for the data. Is our problem statement related to supervised learning, unsupervised learning? Is it classification, clustering, dimensionality reduction, or what it is? Import machine learning model and train your machine learning model on the data which is prepared. Once machine learning model is trained, test your machine learning model on test data, and not to forget, to get the real accuracy, we need to test our data in real data, which is new data point, the data which haven't been provided during training machine learning model. This is to check the accuracy. So once you train and test your model, if accuracy is not as per expected, then we think of fine tuning parameters, fine tuning our machine learning model. Basically, we adjust the parameters of algorithm, and then we again train and test, and we keep repeating steps number 5, 6 and 7, that is train, test, find the accuracy, until we don't get the accuracy as expected. These are the simple steps we are gonna follow to create our demos. Now I'm directly gonna jump on the Jupyter notebook. Let me start Anaconda prompt. So I'll type Anaconda prompt in the start. Let me open the Jupyter notebook which I have already created by going to the directory. So this is the directory where I have all my machine learning algorithm demos kept. So I'm gonna copy this path, cd, paste it here, enter G and Jupyter notebook, Jupyter notebook. This will take a couple of seconds and it will open the notebook in browser. So this is how a Jupyter notebook looks like. I'm under unsupervised learning, so I'm gonna open a very first algorithm which is basics of k-means clustering. This is the IPython, that is a Python code which works on the Jupyter notebook. Is already prepared. I'm opening that. Let me first do cell all output clear to clear the previous execution and the outputs. What are we gonna do here? Only focus on the cursor and the code which I'm showing you. Don't focus on the code and the cells which are down here. The first thing that we are doing here is to prepare the data, is to create two clusters. I'm creating a data here that is blobs. So this will be easier for us to understand the data and understand k-means clustering. What we're doing here, the very first thing is matplotlib inline, just to plot the data inline within this same cluster. We don't want to open the new window. That's why matplotlib inline. Let me execute this. Then I'm gonna create the blobs, that is data, preparing the data by using sklearn datasets. Very simple function that I'm using here is make blobs. How many samples do you want? 150 samples, 150 data points. How many features? 2 columns. How many centers do we want? We need 3. And random state, I kept it 0. You know, even I don't know what all parameters are required for every function, that every Python library that we are using. Okay, so what do I do? For this, I just go to Google and search for the library which we are using. Let's say make blob. I don't know what this make blob stands for. I'm just typing make blobs in Python, and I can open the very first link, which is sklearn.datasets.makeblob. This is from scikit-learn. Basically, it's a documentation which will help me understand all the parameters, the functions, what it returns, what all parameters you can pass, and what is the meaning of these parameters. So here I can see samples, total number of points, features, how many columns, how many features that you want to consider. By looking at this, you can decide what all parameters you are required. Coming back to our demo, so let me execute this. I'm printing X here, shift enter to execute this cell. The star represents this is executing. So we are printing X, that is data points. How many? 150 samples are created. So we got coordinates X and Y of each data point here. So if we scroll, these are 150 data samples. Okay, let me go down. I don't really understand this array, right? So what I need to do is I need to plot the data. Whenever you get the data, plot the data. Thumb of a rule, right? So using matplotlib library, I'm gonna plot a scatter plot. I hope you remember a scatter plot. We discussed this many times in our previous videos. Scatter plot is to plot the data points, is to plot the dots. And in scatter plots, I'm plotting X, Y, that is 0 stands for X, 1 stands for Y. So this is X, this is Y. Show them with a 0, something like this. And show the scatter plot using grid, tight layout and plt.show. Shift enter to see the plot. This is how my data looks like. So these are 150 data points randomly generated by us by using the library which is makeplot. We have generated our data so that I can create a data points, and now I'm gonna use k-means clustering on this data to form a clusters out of this data. Going further, I'm going to use k-means clustering, so that's why sklearn.clusters k-means, I'm doing the import again. Then I'm initiating k-means clustering. Again, this is the most important part here and very easy. Which algorithm we are using? K-means. So we just need to use k-means and pass the parameters and finally use model.fit and model.predict. Is as simple as that. In machine learning, what do we do? First get the data, then decide which algorithm you want to use, train the data on the algorithm, get the accuracy, and then predict the future. It is as simple as that. So now we know if I do not understand what all parameters I have to pass and the meaning of these parameters, I again go to Google and simply search k-means in scikit-learn to understand the parameters. The scikit-learn.org, this is the documentation I want, the very first link. I see many parameters here under k-means which can be used. Okay, so to start with, number of clusters. It's very simple. How many clusters do you need from this data? Then init, how do you want to initialize? Do you remember I told you about seeds, right? Algorithm drops seeds. 2 seeds we dropped, right? So where do you want to drop those seeds? So again, we have algorithms for that. So do you want to randomly drop those seeds, or do you want to use any other algorithm which is k-means plus plus, right? It is an advanced way to drop the seeds by intelligently understanding where to drop the seeds. So you can use k-means plus plus for that. Random is wherever you want, you just drop the seeds so that to create the number of clusters. Explanation is given here, you can read that. How many number of times you want to execute k-means algorithm to get the best optimum results to create the clusters, right? So n init stands for how many iterations you want to do. So 10 iterations is the default. You also have max iterations, which is default is 300. That stands for how many number of times you want to ask the seed, reset, move to centroid. I hope you remember what do you mean by seed and what is the meaning of running the iterations, right? So this is what dropping a seed and then asking, forming the cluster, moving these seeds to the centroid and repeating the same step again and again, which is nothing but iterations which you are doing to create the best clusters with minimum error. Going back to our demo again. So these are the parameters which I have mentioned, right? Currently I want 3 clusters, that's why I'm specifying 3 here. Initialization k-means plus plus, you can also specify random. Number of times you want to execute k-means is 100. Maximum number of iterations I want is 1000. Okay, good enough. And then finally train my model on the given data so that I get predictions, that is y. Shift enter to execute. So this y column will give me what each data point belongs to, which category, which class that each data point belongs to. That machine learning doesn't understand categorical data, right? It will create a clusters and give them numbers 0, 1, 2. So that's what you see here. So very first data points belong to cluster 1. When I say very first data point belongs to 1, that means this. So this is how it has identified what each data point belongs to. Each data point belongs to which cluster. This is what we have identified here. But again, as I said, it is difficult for me to read. We humans are really bad with the numbers, right? So we again plot the data to visualize how it works. So we're gonna plot the output so that we understand how many clusters are formed by again using scatter plot. Don't worry about the coding part, it's really simple. We are just coloring each clusters green, orange and red. If the data point belongs to first cluster, color it as green. If data point belongs to second cluster, color it orange. If data point belongs to third cluster, color it blue. So this is what we are doing here, nothing much. Okay, simple scatter plot we have used. Right, so let me hit shift enter to plot to show the plot here. Beautiful. So do you see the plot here? We have green cluster, blue cluster and orange cluster, and centroids also we see here with the star, right? So we got 3 clusters, something like this, and this is how our raw data, which used to look like this, unlabeled data, raw data, which is converted into 3 clusters, green, blue and orange. Okay, so just to show you, I'm gonna change the number of clusters. Let's say I want only 2 clusters, remaining things I'll keep as it is. And once I make the changes in the parameter, I have to execute again, shift enter, shift enter, shift enter. Let's see how does this creates the cluster. So do you see now 2 clusters? Beautiful. Only green and orange. No, we do not have 3 clusters, though you see the legends, but I see only 2 centroids now. Amazing, right? So this is how you can create as many clusters as you want from the given data. Let me put 4. Let's how does this create the clusters. Let's say 4, shift enter, shift enter, shift enter. Okay, so this is how it creates 4 clusters. 1 2 3 4. So this doesn't look like a proper distribution of the data points within clusters, right? Then the question is, how do I know what is the exact number of clusters? How do I decide how many clusters I should create from given data? For that, I have a one measure, which is nothing but inertia, which is nothing but distortion, which will help me understand the distance from the seeds, the distance of data points from the seeds, so that I understand how much is the data distorted from the centroids. So this is what we have calculated here. So let me see the distortion by using km.inertia, right? So I see 212. So the distortion is 212 here. Let me make changes here and let me put 2 and see the distortion. Let me put 2. If I have less number of clusters, that means more distortion. So let's see. Now I have 2 clusters. So the distortion is also increased. Do you see that? Inertia is increased, distortion is increased, right? Data points are far away from the centroid. That is why error is more. Within cluster sum squared error is more, right? 475. Now currently we have 2 clusters. Let's make it 3. So if I make it 3, for sure the distortion should be reduced, isn't it? Let's see if it happens. I'll change the number to 3, execute these cells again and look at the distortion. It is 262, almost reduced to half. When I mentioned 2 clusters, the distortion was more than 400. When I mentioned I want to create 3 clusters, the distortion is reduced to 262. And when I'm gonna further create more and more clusters, let's say 5 clusters this time, then the distortion will be reduced further. Though clusters doesn't really look optimum, identical, but the distortion is reduced. Does that mean if error or the distortion is reduced, you have got better clusters? You have identified how many clusters you want to create? Answer is no. Less error doesn't mean that you have better number of clusters. That doesn't mean you have better clustering. That doesn't mean you have better clusters created out of your data. And that's how we come to an end of this video. If you have any questions regarding the same, let us know in the comments below. If you found this video helpful, please subscribe to my channel and hit that like button. Don't forget to share this video with your friends and colleagues. Thanks for watching. See you again next time. Till then, take care and bye bye.